read the problem here, okay? Under the graph of, so now I say y equals 1 over x squared. Probably I want to use f of x. To the right of 1. So basically from 1 to infinity, okay? I think we mentioned in Math 101 the way to handle infinity is to use limit. Remember, I told you a slogan before. The tool to handle infinity is to use limits. Okay. I will show you the meaning. I will show you what I mean. Okay. Now the solution. For the regular integral, I mean for the proper integral. Okay. Now the new concept is called the improper integral. So I'm going to use the term proper integral. Okay. It's possible to evaluate the integral from 1 to any number t. No matter, so t value can be 100, t value can be 10,000, t value can be 2, okay. T value can be any number greater than 1. So it's possible to compute the area under the graph from 1 to t, okay. From x value of 1 to x value of t. So the geometric meaning is the area under the graph from 1 to t. So we'll compute that first. Okay. So maybe for t value greater than 1, now we make t to the right of 1. Okay. We compute the area under the graph of the function from 1 to t first. So geometrically, we need to compute the integral, the definite integral from 1 to t, right? Now let's recall the geometric meaning of the definite integral. Okay, from 1 to t, so we integrate the function. Okay, the function is 1 over x squared, and then dx. We'll compute that first. In this case, we need a particular antiderivative. Now we are trying to evaluate the definite integral. It's hard for you to follow using t. You just imagine t value is 100. It's going to be the same thing. Okay. From 1 to t, from 1 to 100, you imagine t value is 100. Okay. In this case, you need a particular antiderivative of the integrand. But in order it's easier to get a antiderivative, you need to convert the function to the form of a power function so that you can use the power rule. Or alternatively, if you can remember antiderivative of 1 over x squared, that's better. Okay. I'm going to use the longer way. Okay. Convert the function to the form of x to the power of -2. I think all of you guys know that. Okay. Now we are ready to evaluate the definite integral. So temporarily, you just imagine t as a constant number greater than 1. Okay. To get antiderivative of x to the power of -2, we use the formula. Okay, you have x to the power of -1, so negative of that, right? You use the power rule. I think all of you guys know what I'm talking about. Okay, and then you plug in x value of t, you plug in x value of 1, and then you compute the difference. I believe the answer is you plug in x value of t, you have negative t to the power of -1. You plug in x value of 1, I believe you have plus 1, right? Subtracting a negative number, you have a positive number. It's kind of that. Okay, so you have something like this. You have 1 minus 1 over t. So do not lose track of the meaning, the geometric meaning. Okay, the geometric meaning of this 1 minus 1 over t is the area under the graph of the function, the graph of 1 over x squared, when x is in between 1 and t can be 10, t can be 100, t can be 10,000. Okay, we'll do that in 2 steps. Okay, so the first step is to compute that. I told you earlier the tool we are going to use to handle infinity is to use limit. Originally, we want the area under the graph of the function from 1 to infinity. So anybody want to tell me in the second step so what we do?
Plug in a large infinite number.
Yeah, we make t as large
A
as
large
possible.
word.
Yeah, we make t as large as possible. So what's that? How can we make that thing clear? T can be yeah, t value of 10,000 is very large, but you cannot use 10,000. 10,000 is not far away. It's not to infinity. How can we make the thing infinity from 1 to infinity? We take limit. We take limit as what? As t approaches infinity. So that makes sense? Again, so geometrically we are trying to compute the area under the graph of the function from 1 to infinity. The next step we need to do is to take the limit as t approaches infinity. So by that we mean the area. Now we're looking for the area under the graph of the function. Okay, the area. I'm going to write it down. Okay, the area under the graph of the function. So now let's say f of x equals 1 over x squared. So now let's say from 1 to infinity is given by you take the limit of the right hand side, right? You take the limit. So basically you look at the mouse cursor. Okay, you just make t as large as possible. You take the limit as t approaches infinity. One minus 1 over t is the area under the graph of the function from 1 to t. We make t approaches infinity. So you are going to have the answer. We're almost ready to have the answer. Okay. I think you know this limit. You have seen this limit in Math 101. So the meaning is as t gets larger and larger positive, as t gets larger and larger positive, the function gets closer and closer to 1, right? As t gets larger and larger positive, 1 over t gets tinier and tinier, closer and closer to 0. And then, so the limit is equal to 1, right? I meant 1 over t approaches 0, so the whole thing, the whole limit is equal to 1. So here comes the definition of type 1 improper integral. Okay, actually, if you look at the beginning of the integral, okay, the beginning of the integral is from 1 to t, 1 over x squared dt. Essentially, we're trying to take the limit as t approaches infinity of that integral. So that makes sense? When t value is fixed, the value of the integral is fixed. I'm trying to say the value of inside the brackets is dependent on t. So the inside the brackets you have a function of t. Actually, in this particular case, the function of t is 1 minus 1 over t, according to our calculation. And then you take the limit as t approaches infinity. You have, so geometrically you have the area under the curve to the right of 1. Okay. So this thing is defined as the type 1 improper integral. We use a notation like this to denote type 1 improper integral from 1 to infinity. Okay, and then 1 over x squared, and then dx. Okay, So that's how we define the type 1 improper integral. I told you the definition. Okay. To define the type 1 improper integral in here, all we need is to replace the infinity part with a number t. You just imagine t value is greater than 1 in this particular case. And then we take the limit as t approaches infinity. The whole thing, so inside the brackets, is actually a function of t. Okay. The first equation is actually the definition of type 1 improper integral. I will show you the definition in general. Okay. Now look at the screen. On the screen you have the definition of type 1 improper integral. Okay. The condition. Now look at the condition. The condition is the function is integrable from a to t. Or put it simpler, you just imagine the function is continuous. Okay. We mentioned before when the function is continuous, it's integrable. But by that we mean it's possible to get the value of the integral. So you look at the equation in here. Okay. The type 1 improper integral is one of the two limit is infinity. I mean the upper limit in this case is infinity. The integral is taken from a to infinity. The definition of the meaning of the integral, it's actually a definition. The meaning of the integral is you compute the integral from a to t and then you take the limit as t approaches infinity. Probably anything using f of x is probably a little abstract. We're going to talk about another example in some more details, okay, so that you know what's going on, you know what I'm looking for. Sorry, I did not open the handout. I'm going to get the handout first. Actually, for question 1, I'm going to show you how to show your work probably, okay, using the same question we just did. And by the way, if you look at the top of the question, you are required to determine if the integral is convergent or divergent, or the integral converges or diverges. It's the same thing. The meaning of that is when the answer to the limit is a finite number, then you say the integral, the improper integral, converges or is convergent. In this particular, so very shortly, I will show you the meaning. Okay, we'll redo question 1 to show you how to tell you how to show your work. Again, the question is asking you to determine if the integral converges or diverges. If it converges, you are trying to compute the integral. Okay. By that, we just mean if the limit is a finite number or not. Okay. If the limit is finite, then we say the improper integral converges. If the limit is infinity, is not finite number, then we say the improper integral diverges, or the integral is divergent. I will try to use alternative terms. Now the solution to that. Actually, for the improper integral, I always suggest you do the whole thing in 2 steps. Actually, it's possible to do the thing in 1 step. I know some of you guys don't bother, but still try to do things in 2 steps to avoid notation problems or mistakes. So the first thing we do is to replace the infinity part with the t. Okay, replace the upper limit with t. So the first thing you compute is for t value is greater than 1, we evaluate the definite integral from 1 to t. Okay, so because we did that already, I'm going to go over this a little bit quicker. Okay, get the antiderivative. I think you have okay. I will still do that slower. Okay, from 1 to t, x to the power of negative 2, and the dx in here, right? Now we get antiderivative. Antiderivative, I believe you have antiderivative of x to the power of negative 2, you have x to the power of negative 1, so negative of that. And then you plug in t, you plug in 1. I think we had 1 minus 1 over t, alright? So that's the answer to the definite integral, okay? The first step you do is to compute that. Again, when the integral is more complicated, try to do things in 2 steps. So the first step, you concentrate on a definite integral. Now the second step, for improper integrals, I'm looking for the definition. Copy the definition. By that we mean the given integral is from 1 to infinity, okay? You copy the given improper integral, given type 1 improper integral, okay? So very shortly I'm going to tell you what we mean by type 1 and type 2 when we talk about when we start to talk about type 2, okay? But now you just remember one of these two numbers is infinity. If that's the case, you have type 1 improper integral, okay? Now I'm looking for the definition. So this step is the definition. How we define the type 1 improper integral. So the thing is defined as the limit as t approaches infinity, right? We mentioned y. From 1 to t. So by that we mean you replace the infinity part with t, and then you take the limit as t approaches infinity. So t can be 10,000, t can be 1 million, but whatever fixed number of t is not sufficient. You have to take the limit, right? Okay, so you have dx in here, x squared. I'm going to underline this part. I'm looking for the underlined part. So this is the definition of type 1 improper integral, okay? So because in step 1 you have computed the boxed part. You just get the answer to the box from step 1. So all we need is to take the limit as t approaches infinity of the function 1 minus 1 over t, right? We have seen the limit is 1. So because 1 is a finite number, so the integral converges. Again, when you see a finite number, you say the integral converges, or you say the integral is convergent. Actually, you can say, so the given improper integral converges to the value of 1, right? In some cases, the integral after taking the limit, I believe you can imagine in some cases the answer could be infinity. If the answer is infinity, it's not a finite number, then you say the integral is divergent, or you say the integral diverges to infinity, or whatever thing. Okay. Again, I think I introduced the concept using the geometric meaning. In this particular case, it's the area under the graph of the function y equals 1 over x squared. The whole area to the right of 1. So do not lose track of the geometric meaning. So any questions about this? For this one, so because the antiderivative is not too hard, it's possible to do everything in one step. So just still, I think it's easier for me at least to do the thing in 2 steps. Okay, now we'll do one other question. Okay. Surprisingly, the area under the curve from 1 to infinity is a finite number. The finite number is 1. Right? Now let's talk about one other case. Okay. So this case actually, if you want, I could rewrite the integral in the form of, so now let's say from 1 to infinity, 1 over square root of x, right? 1 over square root of x, you were not asked to memorize the graph of the function, but I can show you the graph. If you want me to show you the geometric meaning, we're trying to compute the area under the graph of 1 over square root of x to the right of 1. I know there's a way to do the shading, but I forgot. You just imagine it's shaded, okay? The area under the graph to the right of 1. Okay. Now we're trying to compute that area. Okay, now for the solution, I still want to give you the solution in two steps. Okay. So later on, I will give you a convincing question showing you why I want you to do the thing in two steps. So the first thing you do is to compute the integral from 1 to t. You replace the infinity part with t, right? So later on, we take the limit as t goes to infinity. Can I write dx in here? Okay, I used to ask people to guess the area, but it doesn't make too much sense to guess. Okay, I will show you the meaning more shortly. Okay, so we compute that. So what we do is, in order to get antiderivative, it's still easier if we write the function in terms of a power function, right? It's x to the power of -1/2. So because square root of x is on denominator, I'm going to write dx in here. Okay. Again, the answer to the first step, you are going to have a function of t. Okay. Okay, now antiderivative. Okay, antiderivative. We use the power rule. So exponent plus 1. I think you have x to the power of 1/2. If at this location you have 1/2, you invert the numerator and the denominator. You should have 2 as the coefficient, right? What I have written so far is the antiderivative of the integrand. Okay. Now to get the definite integral, you plug in x value of t, you plug in x value of 1. Okay. To see the answer, it's probably easier if you write the antiderivative as 2 times square root of x. 1 over x to the power of 1/2 is square root of x, right? You plug in t and then you plug in 1, right? So I told you the answer to the first step is a function of t. So the function of t is 2 square root of t, right? You plug in t value in. You plug t value up in. You plug t value in. Okay. You have 2 square root of t, and then square root of 1 is 1. You just minus 2. Okay. So we are done the first step. We evaluated that integral. Again, you should have a function of t. In the second step, so do not just take the limit of the answer. You are required to compute the improper integral. You have to copy the improper integral. Again, I'm looking for the definition. The improper integral now is defined as t approaches infinity of the proper integral from 1 to t. Okay, the improper integral is defined as the limit of a proper integral with the upper limit t, right? So all we need is to take the limit as t approaches infinity to square root of t, to square root of t, I mean. Minus 2. Anybody want to tell me the answer to this? Anybody want to tell me the answer to this, please?
Infinity?
It's infinity. Infinity is right, okay. So basically, as t gets larger and larger positive, you just imagine t value is 100. When t value is 100, you have square root of 100 is 10, right? So basically, as t gets larger and larger positive, square root of t gets larger and larger positive as well. I'm trying to say as t approaches infinity, square root of t approaches infinity as well. So that makes sense? So this 2 is a constant, and that 2 is just double the larger number. So the final answer is still infinity. This case is completely different from question 1. This means the area under the graph of that, under the graph of 1 over square root of x, it's not finite, it's infinity. It's infinity, right? So the area under the graph of 1 over square root of x to the right of 1, from 1 to infinity, the area under that curve is not finite, it's infinity, according to our calculation. Okay. In this case, how can we say answer the question? Divergent, convergent? So we say the integral is divergent. Okay. You can just say it's divergent, or more precisely, you can say the integral diverges to infinity. It means the area under the curve from 1 to infinity, the area is infinity. Okay. It's not a finite number. Any questions about this? We have seen 2 particular cases, right? One of them, the answer is infinity. The other, the answer is a finite number. After question 3, I'm going to summarize something, okay? So do you want to try question 3 for a little while? Okay, now let's do this one together. I think all of you guys are good. You can follow me. So this one is too simple for you guys, I guess. After this, I'm going to summarize something. Okay. In any case, you probably still want to write for t greater than 1. the thing will not work when t is less than 0 in particular. So because the function is undefined at 0. In that case, we are going to have type 2 improper integral. Probably we can cover a little of type 2 today. I'm not sure yet. So, but in any case, you evaluate the integral from 1 to t first. Okay, the integrand is the same. All of you guys know the antiderivative is natural log of x. Okay, absolute value of x. I do not have to include the absolute value notation in this case. So because t is greater than 1, we are trying to evaluate the integral from 1 to t. Now you treat x as a number from 1 to t, in between 1 and t. Okay, so it's always positive. If you want, you can include the absolute value notation. It doesn't matter. Okay, but in any case, we are trying to so that's the antiderivative of the integrand 1 over x, right? And then you compute the difference between the value of the antiderivative at t and at 1, right? I believe the answer you get is natural log of t minus 1. Natural log of t minus 1. Okay. So we're done the first step. The second step, the definition. I was too eager to jump to the limit. Now the definition of the improper integral from 1 to infinity, the given integral. Now you see why we call that improper integral, right? It's taken as a limit as t goes to infinity. Again, I want to repeat, the answer to step 1 is a function of t. Okay. So do not get a finite number. It's dependent on t, of course, right? T can be 10. When t value is different, the answer to the limit is different, of course. Right? Yeah. So negative. Sorry. Yeah, natural log of 1. Natural log of 1 is equal to 0, of course. Right? So the answer to the first step is natural log of t. I think Chad told me that. Okay. And then you take the limit as t approaches infinity of the function. So natural log of t, right? For this one, if you can recall the graph of natural log of t, then the answer to this limit is also infinity. Okay. I think you can kind of recall the graph of natural log of t. It's kind of that, right? So this number is 1. As t gets larger and larger, positive, right? Natural log of t gets larger and larger positive. I guess for decimal I have to use brackets probably. Yeah, to use x. Right. Again, as t gets larger and larger positive, natural log of t gets larger and larger positive. By that we mean as t approaches infinity, natural log of t approaches infinity. The limit of natural log of t is infinity. Right. So we're done 3 questions. After this, I'm going to summarize something. Okay. And probably you can kind of see the pattern. Now I'm going to summarize what we call p integrals. And probably in the future you can use the conclusion for the p integrals. Okay, represented by the 3 questions we just did. Okay, So maybe for a p integral, in the form of actually this one can be replaced with any positive number. So now let's say from a to infinity 1 over, so now let's say x to the power of p. I'm going to write a note in here. A is a positive number. A can be 1. I think the 3 questions we did were for the a value of 1, right? Actually, a value can be 2, a value can be 3, a value can be 0.1, a value can be any positive number. Okay. We call an integral something like this, p integral. Okay. I think there are 2 cases. The first case is I was trying to write a small p in here. It's good enough. The first case is represented by p value, represented by question 1. I'm trying to say represented by question 1 when the value of p is a number greater than 1. In question 1, you had p value of 2, right? Actually, it's true for any p as long as p is greater than 1. If p value is greater than 1, then the integral is convergent. And I'll say it is convergent. Converges to what number you need to compute. Okay. But in many cases, we just care about the integral is convergent or divergent. So geometrically, we just care about the area under the curve is finite or infinite. Represented by question 2 and question 3. We can see if the value of p is less than or equal to 1. In question 3, you had p value equal to 1, right? In question 2, I believe you had the p value of 1/2, which is less than 1. Then the integral, it is divergent. For the final exam, there will be some fill-in-blank questions. I give you a p integral. You just need to fill in blank. The integral is convergent or divergent. Now, for instance, if I give you an integral something like this, from 10 to infinity, now let's say x to the power of 1.1. If I want you to if I ask you, is that integral convergent or divergent? So the answer, how do you want to answer the question? Is this one convergent or divergent? It's convergent.
Convergent.
So, yeah, it's because p value of 1.1 is greater than 1, right? It's the first case. The first case in here. Okay. Actually, for the assignment, I would ask you to try some particular cases. Now, let's say the p value of 1.1. Actually, I rarely use decimals. Probably on the assignment, you're going to see something like decimals. So this is actually the same thing as 11 over 10. You could use 1.1. It's the same thing. Again, we call an integral of this form p integral. Okay. Any questions so far? I hope you can realize it's essentially we're trying to talk about how can we define the area, how we can define the area under the graph of a function like that from 1 to infinity. Intuitively, you see there's area, but the rigorous definition, you have to use the integral. Okay. Right. After that, then we are going to show you a convincing question why I want you to do things in 2 steps. In many cases, the integral may not be that simple to evaluate. In this particular case, in the first step, the integral you have to evaluate, you have to use the substitution rule, right? In this case, you have to. It's easier to avoid wrong things if you do things in 2 steps. Okay. So the first thing we do is to evaluate the integral from e to t, right? I forgot to. Still, you have to take t value a number greater than e. We evaluate the integral from e to t. Okay. In some cases, I still do not like this notation. I still prefer to write the thing as the whole log squared. But that's a valid notation, so people do use a notation like that. We'll compute that first. Okay. So do you want to try it for a little while? Or can we make the question in class quiz? In class quiz, please. So it doesn't make sense if I do things all the time. You have to try something. I will give you some hint, okay? For t value greater than e, we are trying to compute the definite integral of that. For this one, we do not have a handy formula. We have to use a substitution, right? So I have to choose u. Anybody want to tell me how to choose u? Choose u. The integrand is the product of 2 functions. Choose u so that one function will be a function of u with easy to compute antiderivative. The other function is the derivative of u times a constant. So anybody want to tell me how to choose u? So please, how do we choose u? Are you trying? Okay, choose u to be natural log of x. Okay. Actually, in class quiz or not in class quiz, it doesn't matter. I'm going to remove this. We just try something together. Okay. I think most of you guys are here. It doesn't matter to me. That's my way to do attendance. Okay, choose u to be natural log of x, and then you compute du, right? Du is 1 over x, and then dx. You know the derivative of natural log of x is 1 over x. Okay. This one is supposed to be a definite integral. You have to compute you have to convert e value and t value to u values. Okay. Right. X value of e. Again, the given integral is an integral of x. This e is supposed to be x value. X value of e will give you u value of of natural log of e, so which is 1, right? X value of t will give you u value of
Hey, sir.
I.
So isn't it in-class quiz?
No, I removed the in-class quiz thing. It doesn't matter.
Oh,
No,
okay,
it's not. Sorry,
okay.
I'm doing too much marking. I hate marking already. I'm not going to do more marking for in-class quizzes. But you are going to have assignments, of course. Okay. X value of t will give you u value of natural log of t, right? The relation of u and x is here. I guess now we are ready to convert the integral to a new integral of u. To a new integral of u, okay. The lower limit is going to be, okay, so keep on writing equals from here. The lower limit is going to be u value of 1. The upper limit is going to be u value of natural log of t, right? And then everything is going to be in terms of u. In terms of u, 1 over x times dx will become du. I mean du. I mean the whole thing circled will be du, and then on denominator you have u squared, right? So do you see why I want you to do things in 2 steps? When the integral is a little bit complicated to evaluate. Now, for instance, if you need to use the substitution rule, if you write everything in 1 step, so this thing is going to be messy. No, okay. So in the first step, you just concentrate on computing the integral from e to t, getting the function of t. In the next step, you just concentrate on taking the limit. Does that make sense? I believe antiderivative of 1 over u squared is negative 1 over u. I think we have seen it earlier. Probably I told you to memorize before. Okay, you do not have to go back to x. At this point, you plug in u value of natural log of t, u value of 1. So basically, you evaluate the function from 1 to natural log of t. I think you end up with 1 minus 1 over natural log of t, is that right? So you see, if you do the things in 2 steps, the answer is pretty clean now. Okay. Now in the second step, you just use the definition to evaluate the improper integral from e to infinity. On numerator you have dx, on denominator you have that. I'm looking for the definition. The definition is this improper integral is defined as the limit as t approaches infinity. Okay, from e to t. I mean, from e to t. Using the answer to step 1. To step 1, you have without the limit, you have 1 minus 1 over natural log of t, and then you take the limit as t approaches infinity. Again, as t approaches infinity, natural log of t gets larger and larger. Natural log of t approaches infinity. 1 over natural log of t approaches 0. So the answer to the limit is 1. So the given integral, the integral in question 4, converges to the finite number of 1. So And then you look at question 5 and 6. Actually, we have two other forms of type 1 improper integral. It's possible to define a improper integral. It's still type 1 from negative infinity to some finite number. Okay. It's also possible to define a type 1 improper integral in the form from negative infinity to infinity. Okay. Now let's concentrate on the type in question number 5 first. Okay. At this point, I think it's not going to be too hard to understand the meaning of the definition. Now look at the second case. The second case is from negative infinity to a finite number. Okay. You just replace the negative infinity part with t, and then you take the limit as t approaches negative infinity. I hope it makes sense. It makes sense, right? And for the last tab, sorry, I lost my screen. Now for the last tab, you look at the screen. It's also possible to define the type 1 improper integral from negative infinity to infinity. You just choose a finite number to convert the integral to the sum of two other types. The sum of two other forms, I mean. Okay. You define the first form. Now look at the mouse cursor. You define that form in step 2. In case 2, you define the last form in case 1, so that it's possible to define an improper integral from negative infinity to infinity. How about I'm going to leave question 5 as assignment question. It's probably one of the questions in textbook. At least it was in my old textbook. That's kind of a famous question. I will give you some hint, but I'm not going to give you the complete solution. I want you to do the complete solution as one of the assignment questions. For this one, I will give you some hint. The first step you do is to evaluate the integral from t to 0, right? Probably you want to say something like for t less than 0. Actually, t is a negative number. Okay. You evaluate the integral x times e to the power of x and then dx, right? So this integral is a typical form for using the by parts formula. Actually, it's you have to use the by parts formula for the definite integral. Okay. I guess for this one you choose u. You let u be x, and you let dv be e to the power of x and then dx. Okay. I'm trying to say you use the by parts formula for the definite integral. Okay. The answer to step 1 is going to be a function of t. Okay. Do that first. And then in the second step, from negative infinity to 0, you take the limit as t approaches negative infinity. The same as before. Okay. The answer to step 1 is going to be a function of t. In step 2, you take the limit as t approaches infinity. This limit is not super simple to evaluate. I will give you some hint. To evaluate the limit, you use the L'Hopital's rule. Okay. The limit is not too simple to evaluate. Use the L'Hopital's rule. to evaluate the limit.
Sorry, sir, did you say this was an in-class quiz?
No, that's not an in-class quiz. That's going to be a assignment question. I will move this to the assignment question. I'm going to release the assignment on Wednesday. Okay. Any questions about this? So basically, I'm going to give you some hint on one of the assignment questions. Okay. And then question number 6. Question number 6. Probably I want to work on this question. Okay. Now let's work on question 6. For this question, you'll have the form from negative infinity to infinity. So you'll have to convert the integral as the sum of two integrals. So you have to choose a point, a number, a finite number. So anybody want to tell me what finite number you want to choose? Choose a simple number. We're going to use 0. Okay. So basically, for this integral, we are going to convert the integral to two integrals. One integral is from negative infinity to 0, dx in here, and then x squared plus 9, right? And then the other integral is from 0 to infinity. So you have dx in here, and then x squared plus 9. Right. We'll do that first. And then we will handle each of the two integrals separately. So how about we concentrate on the second integral first? Okay. For the integral from 0 to infinity, for this integral, we are going to do the things in 2 steps. Okay. Now the first step we do is to compute the integral from 0 to t, right? So dx in here, x squared, and then plus 9. Anybody can remember the antiderivative of the integrand? I think that's one of the questions on your midterm for all the 3 versions. You have the inverse tan of something. It's probably, anybody help me? I don't remember the exact answer. It's probably x over 3 and 1/3 in here. Is that right? I mean the antiderivative of x squared, 1 over x squared plus 9 is that. That's one of the the integrals I wanted you to do on one of the fill-in blank questions. Okay, I will take that as my antiderivative is right. It's probably right. Okay. And then you plug in t. You plug in 0. Okay. The value of inverse tan at 0 is equal to 0. So all we need is to compute 1/3 of inverse tan of t over 3. You plug in t, you have that, right? So this one is the answer to the first step. If you replace infinity with t. Okay. In the second step, we are going to take the limit of that. Again, I'm looking for the answer. I'm looking for the definition. I mean, the definition is from 0 to infinity. Okay. You have dx here. You have x squared plus 9 here, right? So this one is defined as the limit as t approaches infinity of the answer to step 1 of 1/3 inverse tan of t over 3. Good enough? Anybody can see the limit? To see this limit, you need to get the graph of inverse tan of t over 3, or just the inverse tan. I will show you the graph. Okay. Probably the decimals cannot see cannot show the graph very well. It's Math 101. The first week of Math 101, probably. You do not see the asymptote actually. I will show you. It's probably easier if I draw you the sketch. Well, let's say you have half pi in here. You have a negative half pi in here. Okay. You have two horizontal asymptotes. I mean, okay. I'm trying to draw the graph of inverse tan of x. Inverse tan of, probably I can use t. Inverse tan of x. Okay. Something like that. Illustration only. Okay. I'm trying to say if that is the graph of inverse tan of x, the horizontal axis represents x, right? Vertical is y. I'm trying to say as x gets larger and larger positive, the value of inverse tan gets closer and closer to half pi. So do you see it? I'm trying to say the limit as t approaches infinity, the underlined part is half pi. So the answer to the limit should be 1/3 times half pi. I think you have pi over 6, is that right? Okay. Did I make it clear? You look at the graph, you can see the limit. The other limit is very similar. I'm not going to go through the details. I just say similarly. From negative infinity to 0, actually it's kind of by the symmetry of the function. It's also pi over 6. Now the final answer. I will write the final answer here. Okay. Pi over 6 plus pi over 6. The final answer you have is pi over 3. For this question, the kind of weird part is how to compute that limit. But if you can remember the graph of inverse tan or arctan, so the whole limit should be easy, right? Any questions about this? Question number 6. If you don't have any questions, we're done part 1. I think we're done type 1 improper integrals. Okay. Now we'll move on to type 2. Now look at the question on the screen. look at the question on the screen. And now I want you to recall the fundamental theorem of calculus. So this is the case you cannot use the fundamental theorem. Okay. Now let's recall under what condition we can use the fundamental. I think some people just call it FTC, fundamental theorem of calculus, FTC. Okay. This is the case you cannot use FTC. Now let's recall the fundamental. Okay, the fundamental says you have a formula, so something like this, to evaluate the integral of a function f of x from a to b. So the answer is computed using the antiderivative of the function f. We use uppercase f to denote antiderivative of small f. Okay, and then you evaluate the antiderivative from b to a. So this is the statement of the fundamental, right? Of FTC, the fundamental theorem of calculus. But there's an important condition you probably can remember. The important condition is the function is integrable over on the interval from a to b. Or in many cases, the function has to be continuous from a to b. Now you look at the function in this integral. Now the function in this case is so can I write the form of the function to 1 over square root of x? The same thing, right? Now the function is 1 over square root of x. The interval now is the interval from 0 to 1. Is the function continuous on the interval? Is the function continuous on the interval? As a matter of fact, the function is undefined at 0, right? 0 you'll make the denominator of the function 0. So the function is undefined at 0. So you cannot use FTC. Actually, I'm going to show you the graph of the function. Okay, I think we have seen the graph. The function is 1 over square root of x. Can you see the graph properly? I hope you can. So 1 is here, right? 1 is here. So the function is undefined at 0. Now we are trying to define the integral from 0 to 1. So this is the scenario where we have type 2 improper integral. In most cases, the function is undefined at one of the two endpoints. In this case, the function 1 over square root of x is undefined at 0, right? And it's continuous at everywhere else. I'm trying to say, in this case, this function is continuous on the interval from 0 to 1. If 0 is not included, I'm using round brackets here, right? I'm trying to say the function is undefined at 0, but if you something like this, so 0 is here, 1 is here, the function is undefined at this point. Can I use a circle to indicate the function is undefined at this point? But the function is continuous at any subinterval from t to 1. I'm going to use t. Okay. Hi guys, I think I lost internet, so something was wrong earlier. Can somebody confirm you can hear me now?
Yeah, I can hear you.
I still have the message we have bad internet. I'll check if I think the internet is okay. It's back to pretty fast speed actually. Now the internet, I'm pretty sure the internet is okay now. You can still see the screen, I guess. Huh? I think I lost the internet for 1 second. Okay, now the idea is the function is undefined at 0. The function is undefined at 0. If you look at the graph of the function, probably it's easier to see the graph too. The function is undefined only at 0. Now look at the mouse cursor, okay? So the function is continuous on any subinterval from 0 to 1. So it makes sense to evaluate the integral from, now let's say, t to 1, where t is in between 0 and 1. Can I say that? So essentially, this is a type 2 improper integral. Okay. I will show you how this thing will work. I will show you the full solution, and then you are going to see the meaning. So geometrically, we are trying to evaluate the area under the graph of 1 over square root of x from 0 to 1. From 0 to 1. In this case, you try to understand the meaning from 0 to 1. And the function is undefined at 0, but the function is defined at any point, at any number slightly to the right of 0. So 0 is the point with problem. Can I just say that way? 0 is the reason why we have an improper integral. So 0 is a point with problem. Now I guess you know how we handle that. I will show you the solution. Again, the function, the integrand is undefined at 0. 0 is the point with problem. That's why we have an improper integral. Okay. And then how can we define the integral even? We replace 0 with a t. Okay. It's possible to evaluate the integral from t to 1 as long as t is a number slightly greater than 0. I hope you can see that from the graph. You make the point t, so somewhere in here. So we can evaluate the integral from t to 1. The geometric meaning is the area under the curve from t to 1. As long as you make t slightly to the right of 0, then the integral is defined. You make t slightly to the right of 0, the integral from t to 1 is defined, right? We'll compute that. It's kind of the first step. You get the answer to the first step is again a function of t. Okay. From 1 to t, the integral now is x to the power of -1/2. I think we have seen that before, right? And then you have dx. In the first step, your target is to get a function of t. Okay. You get antiderivative of the integrand. I think we have seen that before. Antiderivative of the integrand is 2 times x to the power of, I'm not going to run too fast, x to the power of I think 1/2. -1/2 plus 1, you have +1/2. Okay. You plug in 1, you evaluate the antiderivative from t to 1. I think the same thing, you have 2 square root of t, which I just convert x to the power of 1/2 to square root of x. Okay. From 1 to t. I think the answer to that you have is you plug in 1, you have 2, right? Square root of 1 is 1. 2 minus 2 square root of t, is that right? So do not lose track of the meaning. The answer to the first step, I mean the answer of 2 minus 2 square root of t is the area under the graph from t is slightly to the right of 0, from t to 1. Okay. Now the next step is the definition of the improper integral. This integral is improper because the function is undefined at 0 in this particular case. 0 is the point with problem. So anybody want to tell me how to make a connection with that? You can write the answer in the chat, or you can speak up. Probably it's hard to write in this case. The improper integral from 0 to 1 now should be defined as the limit. You take the limit as t approaches what?
0.
0 from what direction, please? Actually, we need
Positive.
0 from the right. So because t is always positive, so that makes sense. Now look at the mouse cursor. So t is here. T is always to the right of 0. The actual improper integral is from 0 to 1. So that improper integral is taken as t approaches 0 from the right. So that makes sense. T is always to the right of 0. I haven't showed you the definition yet, but I think you got the idea. So now the bottom line is you do need to realize the integral is improper because the function is undefined at 0. To handle an improper integral, you have to take the limit of some proper integral, right? When t is slightly to the right of 0, then the integral is proper. So basically the improper integral is defined as the limit of a proper integral. I know not all my terms are rigorous. People do not say proper integral and so on, but I'm trying to tell you the idea. Okay, so all we need is to take the limit as t approaches 0. You look at the integral part. The integral part is the answer to step 1. You take the limit of 2 minus 2 square root of t, right? This limit is simple to evaluate, right? Sorry, t approaches 0 from the right. I said many times approaches 0 from the right. I forgot to write it myself. So the answer is 2. I hope it makes sense as t gets tinier and tinier, as t gets closer and closer to 0. Square root of t gets tinier and tinier, right? Or alternatively, I think in Math 101 we learned to evaluate the limit. So because the function is elementary function, we just plug 0 into the function, we have the limit. Right? The same as before, because the integral is an improper integral, although it's type 2. I haven't told you what is type 1, what is type 2, right? Type 1 is when one of the lower limit and upper limit is infinity. I mean, in the integral, when one of the lower limit and upper limit is infinity. And then you have type 1 improper integral. Okay. When the integrand is undefined at any number on this interval, you have type 2 improper integral. In most cases. So for an improper integral, you need to answer the question, is it convergent or divergent? Converges to what? So in this case, we say the integral converges to 2. Okay. Converges to 2. Any questions about this? Actually, the definition of the improper integral is in the course manual. Again, for the solution, I'm looking for the second step. By that I mean I'm looking for the definition. Okay. Now I will show you the definition of the on the course manual. Okay. Type 2 improper integral. So the first case is probably the case we have seen, right? No, actually, the question we have seen was the second case. You imagine a value was 0, b value was 1. The function was 1 over square root of x. That's actually the question we did. Okay. It's kind of the function is discontinuous or undefined at a. The question we did, the function was undefined at 0, right? It's kind of discontinuous is more general case. You just imagine in most cases it's undefined. Okay. So in this case, the improper integral a is the reason you have an improper integral. Okay. You replace a with t, and then you take the limit as t approaches a from the right. And likewise, you have other cases. Yeah, probably the next question I want to show you is a question something like case 1. Sorry, I don't have a whole lot of time. I want to do the questions in order now. Okay. And then now let's work on question 2. Okay. For question 2, 0 is still the reason you have a improper integral. Do you see the integral and the function is undefined as 0? The integrand is not continuous as 0. In particular, the function is undefined as 0. Okay. So in this case, we have an improper integral. Probably after this question, we're done. So the first step, the function is undefined as 0. So the first step is to replace 0 with t. We evaluate the integral from t to 1. Okay. You have to make t slightly to the right of 0. Okay, I'm not going to run too fast. I'm going to convert the integrand to the form of a power function x to the power of -2, right? Sorry, I did not see your question earlier, Chad. When the integral, when the limit is infinity or does not exist, that's the case when the an improper integral is divergent. When the answer is a finite number, the integral is convergent. Is that your question, Chad? Yeah. I think you are trying to ask p integral. Yeah. You are trying to ask p integral. So later on, I'm going to summarize the p integral for type 2. For type 2, it's different. This is a type 2 improper integral. The two cases I summarized earlier is true only for type 1 improper integral. You remember the p integral I summarized earlier? It's the p integral for type 1 improper integral. Right. For type 2 improper p integral, I'm going to summarize later. Okay, probably not today. I think I got the proper answer to your question, so that's what you meant. I'm pretty sure that's what you meant. Okay, now antiderivative of x to the power of -2, you'll have negative x to the power of -1, and then you evaluate the antiderivative from t to 1, right? So the answer to that is again 1. I think you have something like, so give me a little moment. I think you have something like, you plug in t, you have 1 over t, right? Positive 1 over t minus 1, is that right? So that's the answer to step 1. In step 1, we evaluate the integral from t to 1. Okay. And then in step 2, I'm looking for the definition. 0 is the point where the function is undefined. So that's why you replace t with 0 with t. You evaluate the integral from t to 1. And by the way, the function is continuous at any point in between t to 1, as long as t is positive. Actually, more strictly speaking, I should mention t as in between 0 and 1. I'm looking for this step. Okay, you take the limit as t approaches 0 from the right again, right? Using the answer to step 1, you take the limit as t approaches 0 from the right. You take the limit of 1 over t minus 1. Anybody want to tell me this limit? As t gets closer and closer to 0 from the right, from the positive side, 1 over t. No, it's not -1. 1 over t. So just imagine as t gets tinier and tinier. 0.1, 0.01, 0.001, 1 over a very tiny number is very gigantic, right? Does that make sense? This limit is infinity. I hope it's as t gets tinier and tinier, 1 over t gets larger and larger. The limit of 1 over t is infinity as t gets closer, as t approaches 0 from the right. I hope it makes sense. So this integral diverges to infinity. I will also show you the geometric meaning of this one, okay? if you look at the graph of the function 1 over x squared, your 1 is here. We're trying to so geometrically the integral we just computed is the area under the curve when x is from 0 to 1, right? This area is infinity. Okay. From type 1 improper integral, the area to the right of 1 is I think it's a finite number. The area under the curve to the left of 1 from 0 to 1 is kind of infinity. Okay, so that's the answer to question 2. Okay.